the order again?
It will be, I will give a very quick introduction, then Maxime will have around 5 minutes to give an overview what happened after the workshop. Then it's you, Paul.
Okay.
And then we get into the pilot. First Josep Maria and then Luigi. And we hope to have 10-15 minutes in the end for Q&A.
Okay then.
If you have any issues during, then you can use the chat box to send only me or also the other panelists a message. Just make sure you check that you're not talking to the whole audience. Yeah, okay, great. So we're going to start now then.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone. I hope you can see my screen. Welcome to the webinar and thank you for joining. I'll just give a quick introduction into what the next 1 hour will be about. First we will launch with an introduction to the project and the transport domain with Maxime Flamand from Ertico. Then Paul Kampfner will talk a bit more about the potential of big data in transport and what we learned at the workshop in September. And then we will come into the more practical part with the pilot in Thessaloniki. First with the pilot partner CERT. Josep Maria will give his presentation, and then Luigi Selmi will show us a live demo on how the pilot works and let us know what the second cycle will bring in the next year. We will have a short 10, hopefully 15-minute Q&A session in the end, so please feel free to post your questions in the question panel, which you can see here. It's on the right in the collapsible menu. The participants will be muted, so this will be your way of communicating with us. Also, if you have any issues, you can find the settings in this webinar interface. If you would like to learn more about the project, then we invite you to visit our website, subscribe to our newsletter, or you can follow us on various social media. These presentations will be made available on the website afterwards, as well as a recording. So I will give the floor now to Maxime to launch his presentation.
So thank you very much, Andrea. It's a pleasure to give this introduction. We are now in the second year of the activities within Ertico on really looking at what big data can do for transport, and we really appreciate the importance of the BigDataEurope project to help us understand these challenges. So big data is clearly something that is a transversal activity. It's an activity that can help many different societal challenges, and among them, of course, transport is looked at as one of the place where big data can make a very important difference. And this whole big data is enabled by many different factors, and so you have around big data things like the easy data collection that we are facing now in transport, the easy, more and more easy storage capacity and increased storage capacity, the computing power that is increasing every day, and we see even mini supercomputers now in the different vehicles, especially the most innovative ones nowadays. A large amount of sensors that are around vehicles and around other roadsides and also very importantly the communication technologies that are improving as we speak. And so all this results in a near-time use and transmission of massive amounts of data, and big data really helps us to make some sense out of all this. So across the chain we have all the elements in transport to make really big data help the transport, and we have to put this into a framework for better using these opportunities. So it goes from acquisition, recording from the vehicles, from the roadside, but also from all kinds of other tools, travel planners, etc., and time schedule, timetable, all what we can do in terms of what is moving on our roads. And this goes, of course, with a very large heterogeneity of the kind of data, real-time information, large scale, velocity and timeliness is there, and then also very important point is the privacy issues related to the large amounts of data that is being collected in transport. So this then from acquisition, you're extracting, you're going into the integration, aggregation of the information, and very importantly, at the end of the day, you have to add value to what is being displayed to the driver or to the user, and the interpretation of these data is still a key thing that needs to be done. And as long as we don't have really open data chains, we still, I think, in a suboptimum position to really make very good use of all the data that is available. And the other challenge is that in big data in transport we have an extremely vast set of different purposes that are applicable here, and it goes from better public transport, but also better urban planning, real-time traffic information, fleet logistics, product development and vehicle monitoring, and eventually also evaluating customer satisfactions, understanding also behavior of drivers. It's so large that we have to focus. And one thing that happened over the last 2 years is the improvement of, or it's a kind of change of mindset from different siloed information, and really going to look at open data and share the data, and look at all the impacts that can come from this shared data. So the impacts are in large variety. We look at resource efficient transport, safer mobility, better informed door-to-door mobility, less congestions and unforeseen delays, socio-economic and behavioral understanding, the issue of personal information, also better better informed policy making, and finally this all leads to some kind of global leadership that European transport should take. And the mindset that I was mentioning earlier is really the reflected in the mobility as a service, and mobility as a service has really emerged as one very big trend over the 2 last years, and I think in the last workshop it really came into the picture as an obvious case for big data in transport. And I would really like to thank also the different people to bring this on the table and evaluating more how BigDataEurope can contribute to the mobility as a service. So with this, I would like to thank also Andrea and Paul, who were there at the workshop last time, and I'm letting then Paul give his view of of the whole picture.
Thank you, Maxime. So the floor is yours, Paul.
Okay, thank you. Right, thank you very much, Maxime. That was a very good introduction, and I'd like to maybe present a slightly different perspective on that. Just to say, Christmas is coming, and I couldn't resist showing you this one. Yeah, let's carry on with the transport. So this is a really quite an interesting picture. What's going on here is that for Spain, there's a big data company which actually belongs to a bank, and this is a picture of transactions using credit cards. And what they're able to do with that is they know exactly where the card is used, because it's used in a machine somewhere, and the machine is in a specific location. If somebody uses it from a mobile device, it's less obvious, but from this information they actually get a lot of locational intelligence simply from analyzing people's bank card transactions. I bet you didn't know that that was going on, or potentially could be going on with your bank card transactions. This is supposed to be anonymized, but they are actually selling their database to the to city traffic authorities, because they are actually tracking where people move to between from one transaction to the next. This is kind of a snapshot at a particular time. So what's interesting is that it shows that, and this is I think a real big data case, you can use big data collected from something completely different from transport and still use it for transport purposes or mobility purposes. So just a few reflections here. Quite clearly big data can yield surprising information, and I think that's I'm sure we will continue to be surprised about what kind of things you can learn from what kinds of data. But of course big data in itself doesn't have any special or specific value unless there really is a purpose to use it. And I think that's an important point to come back to. Is we need to start in a way from purposes and say then what kind of questions can big data help to answer. So from the transport and mobility community, what things do we want to know that we don't know now or cannot collect now from our existing means? Because that's kind of what big data is about. It's about bigger data sets than people can handle with typical applications at the moment and techniques, and an ability to store and analyze data with new analysis methods as well. And some of those products to do with big data, some of the techniques are certainly now available, commercially available. They are through a BigDataEurope project, they are brought closer to application, closer to a larger audience to use, and especially with the transport use case. And you will see the potential for that in a very specific way in the pilots. I think until now, despite what Maxime says, it is certainly coming very rapidly. In some cases it's here. Transport is not one of the biggest domains in big data. A lot of what is considered to be big data in transport is manageable with today's technique, so that doesn't really qualify it as big data. So there is clearly, as I've shown you, potential value to transport and mobility users in non-transport source data. So we do need to start looking beyond the directly transport and mobility sources of data. And the last question then, so which big data in particular can give us added transport value, if I can put it that way? This is a nice overview coming from the mobility group at the Free University of Brussels. Smart mobility is in the center there, and you see some of the things that Maxime has mentioned. Different kinds of mobility, such as automated and cooperative ITS, or logistics, electromobility. And what they don't put on this picture is mobility as a service, which I would like to spend a bit more time on. And you see these kind of technologies like sensor networks, fixed and mobile, well, and the big data analytics and the cloud computing, all of which is necessary. And it's all founded now in the mobility sector, it's all founded on mobile communications, or a lot of it is. So that's this kind of overview. Where is it going? Well, connected and automated vehicles. Already, if your car has an internet connection and it's got, let's say, a forward-looking camera for speed limit and roadside recognition, which cars have had, production cars have had for some years now, and in the future with automated vehicles. An automated vehicle only works when it has a huge bank of different kinds of sensors, as radars and lidars and cameras. So potentially there's going to be a truly vast quantity and variety of data coming from vehicles in the future, both connected and then later automated. Don't forget connected travelers, because anyone who's traveling who has a smartphone connection, internet connection, is going to be receiving, let's say, mobility services, but can potentially be sending information about where they are, how they're traveling, and how conditions are. Then mobility, it's part of the whole smart city paradigm, and smart cities are becoming very fashionable. So I see the mobility within the smart city as growing in importance. And again, this is a requirement for extra intelligence and information. Another tendency is demand responsive and shared transport. This again requires connectivity. It does create some interesting potential for data collection from users. Electromobility needs to be connected, but it doesn't necessarily in itself need big data. Smart logistics, on the other hand, probably is a good case for for big data, because you're not just looking at vehicles, but you're also looking at individual parcels and cargo items. At the bottom I've added mass, because I think this is it's a fashionable term, it's a fashionable idea at the moment. The only place where it's really working commercially is in Finland with the mass global service, starting from the Helsinki area but eventually becoming a national service. This is interesting because it does combine a lot of the things above there. But what's interesting in particular about it is that it's provided by a service provider. And I've been trying to wonder who will be the real drivers for the use of big data. Now, a lot of big data sources come from public authorities, for example, or public transport operators. But the mass operator at the moment, in the Finnish example, is a commercial company who wants to make some money from this. So in fact, we've heard already what are the sources of big data for mobility: vehicle sensors in the infrastructure, the internet of particularly moving things, where things have an internet connection and can be followed or steered or controlled or polled. And then the user's mobile devices. Now that's the device itself sending information about its position and other conditions about the device. But in the mobility as a service paradigm, as a user, as a private user, you are using your journey planner application in your device. And there, what it's doing is you're telling the device where you want to go, when you want to arrive, your specific characteristics about you and your journey. There's a lot of information about your journey in there, which at the moment is going straight to the mobility as a service broker, but it's not something, because it's commercial information, it's very unlikely to be shared in a big way as open big data. Social media already being widely used now for information of where people are and what they're doing and different types of activities. And as I said, maybe we should look at other possible associated systems like use of payment cards, in what that tells us about people, where they are, and what they're doing. So my last slide, and I hope this will provoke some questions and discussion. Starting with mass and mobility as a service, it will certainly depend on big data handling. And that's what this service provider, who's a broker, does. He gathers demand data from users, from their journey planners, but he turns to a whole range of transport suppliers to provide the vehicles and the services needed to fulfill the customer's journey plans. And a customer's journey plan, if it's a journey that's going to take an hour or so, the plan, if it's fully detailed, actually gives a very detailed view into the future. So it's more than prediction. It's pretty close to a genuine view of the future, unless people's plans change for some reason. So the conclusion is that transport service fulfillment, which is the providing that mobility service to the user, it's by arranging a lot of different transport services. So someone may want a bus, they may want a private car, an Uber car, they may want to use a shared bike, or they may need a specialist form of transport. For the broker and the service provider to arrange all that, he needs to have an access to all of the data, real-time data, and the booking data necessary to actually buy those transport services in order to deliver them to the users. So this I do see as a really interesting and commercially based but fascinating future need for big data. To come back to the toolbox which this BigDataEurope project is actually creating and delivering, I think I'm really interested to know who the customers will be, and I hope some of the potential customers are in the webinar. Who would be the actual owners and operators of who would implement it and then operate the big data as a service, if I can put it that way. And then what is the long-term business plan for this toolbox and for the project? So it's important that something is put into place, a sustainable sustainable business plan for future operations. Otherwise, we lose the benefits that we're gaining from this project. So I'll finish on that point, and I think it's a very valuable project. I think the toolbox will be extremely useful for applications in the transport world. But let's hear some more about that from the pilots. Thank you.
Thank you, Paul, for the really interesting presentation and for setting the scene for the project. I will hand it over to Josep Maria now from Thessaloniki, who will tell us more about this pilot and what they have been doing.
Thank you, Andrea. Okay, can you see the slides?
Yes.
Okay. So I will talk you about first about our dataset we have in Thessaloniki, and then how we are using it for the project. Second, I agree with Paul that it's not clear yet that in the transport domain we have big data needs. This is, for example, when we were asked about what kind of big data we have. Okay, we have data from a fleet of vehicles, we have data from users, from mobile phones, but we were able to process all this data. So the interesting thing with big data is that we thought that maybe we can do things, we can process the data in a way that we couldn't in the past. So maybe yes, we can cover the needs we have now for our transport services, but with the big data we will be able to process the data in a way that we didn't know that we could. We will be able to use historical data, almost analyze it in real time for building patterns, for example, for predicting. So this is what we decide. Since everything at CERT was already working, we find one interesting case that we couldn't do in the past. So now we can do it using big data. So this was our most our interest to participate, to do something new, because we really need these tools. So in Thessaloniki we have three kinds of sensors. We have what we call a stationary sensors network, which means that the sensors are static. We are collecting Bluetooth MAC IDs at 43 locations. We have a second network of sensors, what we call dynamic sensors fleet. We are receiving the data from more than 1,000 taxis in Thessaloniki. They are constantly sending the data to us. So we can use these two data sets. We are doing these two data sets for providing travel time and traffic status estimation in real time to the users. We can extrapolate traffic flow. We can build our origin destination matrices that we need for our planning studies. We can calibrate our models. And the new capability that we have now and we are working in within this project is to understand the mobility patterns from the users using all the datasets, the conventional datasets with from cameras and loops, the Bluetooth detections, and the floating car data. So we are able to predict what will happen. So this is our added value. That we are receiving this added value from the project. So it's clear that these tools are useful. So now we are able to estimate mobility patterns, but we are able also to predict what will happen on a short time, in the next hour, for example. Finally, the third data set is out of the project because we are still understanding this data set and it's not representative, but it has, I think, a huge potential, and for the reason I want also to present it, is data from social media. Our most interesting data set is from Facebook. We are collecting check-in events, so we know when and where people is going for leisure activities. People is not checking in at home or at work, but they are checking in at restaurants, at bars. So this data set will complement our traditional data sets, which are more related to home work trips with leisure activities that it's really hard to obtain data on this side. So for this presentation, I will go to our site because I think it's better to see something live than just pictures. So I will go to our desktop or our traffic monitoring center, where you will see live the taxi situation, the taxi locations, and the Bluetooth network. So this is our desktop. We have different data monitoring tools here. If I open the taxi window, we can see in Thessaloniki live now what is the location of at this moment 783 vehicles which are in the city. 400 of them are moving. So at this moment we have 400 speed measurements in Thessaloniki that are being updated each 6 seconds. I can click on any of the taxis. I can see the speed, 30 kilometers per hour. I can see if there is a passenger or not. The green ones, they have a passenger. The yellow ones, they have no passenger. The red ones are just waiting at taxi stands. So this is one of our data sets. You can see that the last update, it was, I think, 1 minute ago. So we have a small delay of 1 minute, but it's quite real-time data. And we are using this data in order to build or to provide this service, which is the same background. It's in Thessaloniki. The users can see how we aggregate all these taxis, giving us their speed at this location. We aggregate the values and we are giving to the citizens, to anyone willing to use this data, what is the number of taxis, 30 in the last 15 minutes, and what was the speed, 19. So you can see that at night the speed is near 40-50, which is the free flow speed, but you can see when there is the speed drop starts during the morning peak, and during the whole day in Tsimiski the speed is between 15 and 19. So any citizen willing to go somewhere in the city can check the status of the network and choose the best route. Our second dataset is this network of Bluetooths, which I will show you here. We have a total of 43 Bluetooth detectors in Thessaloniki. And what is interesting is from each pair of Bluetooth, we are estimating the travel time. So we are collecting MAC IDs from anonymous users, and if we have a match between two locations, we can estimate the travel time between these two locations, not from one user, but from a small sample of users. And we end up to this service that you can see a lot of routes, small routes within the city. We are telling what is the route between two locations, which means that we have one Bluetooth detector at each of the two locations, and the travel time is 7 minutes. So again, the user can see what's the path that we are telling them that the travel time is 7 minutes. He can also see the historical data for the last 12 hours. So again, at night, the flow travel time of 3 or 4 minutes, but during the day we can see the morning peak, we have travel times of up to 10 minutes. So again, the user can decide what route to follow or what route to use within the city, knowing what is the real-time situation in Thessaloniki. So you saw this service, which is the traffic status. You also see the service, which is the travel time along different routes. Finally, all this data, we are giving it as open data in our opendata.imed.gr. So anyone can download this data. They can build their own historical databases. And this is how we are providing the data for the project. So the project is taking the data from our open data platform and using the tools. So it should be easy to apply the same algorithm, the same methodology to data sets from other cities if they follow the open data standards. You can see our open data sets, and for each data set you can download the data in different formats, or you can even build APIs. So you can build services on the top of this open data. Finally, about the social media data, you can see here, for example, the profile of the check-in events in the bars and the coffees of the city center. It's interesting to see the pattern. Here we have 7 days, so you can see every day there is a small peak on the afternoon, at night at the bars, on the afternoon at the cafes. During the Friday and Saturday, there is a quite more important peak. And now we're trying to merge all these data sets. For example, we understand that since these activities are related to leisure for the people, they may use a taxi. So you can see here the correlation between the check-ins and the taxi rides, the origin or destination of every taxi ride in the city. During the morning and the afternoon, the fit is very bad because people is going to work and they are not checking in at work or at home. But you can see at night or evening and late at night, you have quite a good fit because people is checking in when they are going to the bars, to the restaurants, and they are using taxis more than when they are going to work. So we can see that these two data sets are related. Again, the green line is for the 7 days of the week. Again, on Sunday we have a very good match because on Sunday people is doing their leisure activities. During the week we have a worse fit because we have the trips to work and home. Just a good picture. You can see here the center of Thessaloniki. In red color you have the check-in events. In blue color you have the origins and destinations of the taxis. So this is the night situation. So you can see the fit between all these people taking a taxi here. They are going to this area for having a drink. All this area in Thessaloniki is very active at night. So we have a lot of taxi origin and destinations. So these were our data sets in Thessaloniki, and what are we doing? How are we using them in the BigDataEurope project? First of all, we started with this idea. We have the Bluetooth data from the Bluetooth detectors. We have the floating car data from the taxis. So first of all, we need to match the data from the taxis to know each taxi in which link is circulating. Once we have this match, we can merge the data from the travel time from the Bluetooth with the traffic status from the taxis and predict what will happen. What do we mean with predict? We don't want to build a time series model, an ARIMA for example. We want to take advantage of that we have a very good coverage of all the streets during the whole day. So we may be able to find patterns, for example, local markets. We have local markets in Thessaloniki that every Tuesday morning they are closing a part of the city. So if we understand that there are no taxis circulating into this region without defining this region, we can see that the pattern is starting, so we can find on our historical database what is the impact of this local market. So we want the data to tell us not what is happening. I don't care if it's raining or if there is a local market or if there is a strike, but the data can understand what will happen because they saw the same pattern twice this month or a few times during this year. So this is what we are dreaming in building. So for this we need big data because we are analyzing the data from all the taxis, from all the Bluetooth for 3 to 4 years. We need to analyze this in a few minutes. So this was our reason to move to big data. On the first pilot, we built everything with not with the final algorithms, which will be built in Pilot 2 and Pilot 3. We want to use topology-based map matching because it has a better improvement. But what is important, if in Pilot 1 we start with a simple ARIMA model, a time series, we want to go to ARIMA X or even use neural networks, so we can use the data not only the temporal relation, but the spatial relation in the data. And we want to build this pattern recognition and prediction component, which it will be the added value of this project on the top of our data. We have this representation of the map matching algorithm, where we are just checking that each next position is feasible, knowing the topology of the network. If this street, if the next street is on the opposite direction, we will not match it to this link, for example. If it's forbidden to turn right, we will not match this link, we will find another link. For example, you can see here what's the mistake. We have two routes, one green, one in blue. The map matching is telling us that this taxi is doing this movement and then it's going here, but this is not feasible. So these points should be somewhere here. So with the topology, we would see that from this link, we cannot go to this link. So we would correct this. It's only 3%, more or less 3 to 5% the errors, but we want to be very accurate and we want to go to less than 1% errors on the map matching because this will have an impact on the prediction algorithm. So finally, this is our traffic classification and prediction algorithm where we are giving data from conventional detectors, loop, cameras, data from the taxis, voting car data, data from the Bluetooths. We will have a huge historical database and we want in real time to analyze all this data to find the pattern and then tell us the prediction. What will happen? Because, for example, now it's raining. I don't want to know that it's raining, but the pattern tells me that it's raining, so the congestion will be higher than on a normal day. So these are our data sets. This is what we are doing on the BigDataEurope. And I understand that you will have questions at the end. I will be happy to answer them.
Thank you, Jose Maria. Actually, we already received a question that maybe you could quickly answer. It was asking what percentage of the vehicles are detected by the Bluetooth sensors?
Yes, this is a good research question. We are presenting a paper on the next ERB Congress. It was surprising because we expect less detections, but we are near to 20% of the cars being detected after applying some filters. we are detecting mobile phones, hands-free, or even cars with built Bluetooth environment. So yeah, it's more or less 1 out of 5 cars we are detecting them.
Thank you. I'll hand it over now to Luigi. We're running a bit late, so I would like to ask him to walk us through the technicals and the potential of the next cycle for the pilot. Luigi, I believe we can view your screen now. Yes. Luigi, something doesn't seem to be right on the screen and we can't hear you.
Can you hear me now?
Yes, yes.
Can you hear me now?
Yes.
Please don't use the presenter view so that we see the...
Can you hear me now?
Yes?
Yes.
Okay. Can you see my screen?
Yes.
Yes, but don't use the presenter view, please.
Okay. You cannot see the slides when I use the full screen?
It looked strange.
It looks like the presenter view, so click on the presenter view. Untick presenter view. There. Yes, okay. Yes, you were there.
Okay.
Maybe if you just zoom in a bit.
Yes, otherwise I can use this one, probably that's better, I hope. Can you see now?
Perfect.
Yes, that works. Perfect. Thank you.
Okay. Okay. So I was saying that the objective of the pilot is to implement the services that have been implemented by CERT using the big data framework, open source software. So the idea is to process the stream data because in the case of the traffic, as has been said before, it's a matter of dealing with the unbounding data set. It's not the static data. It's data that comes in quite quickly and must be processed quickly because the value of the data is lost in a short time. So the architecture that we are using is based on the microservice architecture. That means that you have a broker where different components can communicate and share data. So we have a component that produce the data. That means they fetch the data from web services or from other sources, batch file or web service, and they provide the data after some transformations to the other components, and then usually there is a result from the processing that is stored in a database, and usually from a web application this data is accessed for visualization. So we choose among all the many components that are available as open source to deal with big data sets in distributed environment. For the message broker, we have chosen Kafka because it's a messaging system that works like a log where the components can send data and this data can be consumed by other component. this framework can be distributed because this is the main work from our side. That is how to distribute the processing, the storage of the platform. So as you can see, for Kafka, the distribution of the data can be is done using the concept that is the topic, where producers send the data for other consumer to use the data. And the topic can be partitioned and replicated in different nodes, so that the data will the service will be fault tolerant and scalable. Then after the messaging system, we need to process the data, and we have chosen Flink, that is a framework to process stream and batch data. In our case, is more stream, but we have also historical data from SER. For example, we have 44 gigabytes of data from of historical data of the floating car data from CERT. Also in this case, Flink can distribute the process to different nodes. We can set the number of nodes and the number of partition where in which the processing can be split in order to be faster. For example, in the case of the pipeline that we use for processing the floating car data, we need the first step is the map matching. That is quite demanding as an algorithm, and also in the future for the next cycle will be the training of a model for the prediction. So we need to be able to distribute the process of this data. I move quickly because there is not much time. Then the other components are PostGIS. In PostGIS we store the road network. Because the distribution of this data will be simply a replication of this database in all the nodes, because the road network will not change in a fast way. We need to know which is the road network, and this road network will not change in let's say in few days. On the other side, the data that we get from the taxis is always increasing, and this project is not only to process the data from Thessaloniki, but the idea is that of course we could cover area bigger than a city, and so we need to be able to handle the data, even bigger data than that what we currently use in the case of Thessaloniki. So for this we use Elasticsearch because it scales very well. It's fast. It can index the geospatial data, and so it's very fast when we send query to see, for example, how many vehicles are in a road segment. Also, Elasticsearch has its own way of splitting the data, the indexes in this case, and we had to think that all these components, they live in each node. We will have PostGIS, we will have Elasticsearch, we will have Flink, because all these will be worker in the case of Flink, and shard in the case of Elasticsearch, but each node will have any of these components. This is the architecture of the pilot for the second cycle. So we will focus our work on the historical data. That is the big data set. And for the process will be to first do the map matching. That means matching the coordinates of the vehicles to the road segment identifier, and then aggregate this data in order to know which is, for example, the average speed in a road segment, which is the number of cars that are in each road segment, and then with this information, with the time window, for example, of 15 minutes, we could also train a model for the prediction. Then we have also we can also talk maybe later about the different visualization. I go fast. One other feature of the BigData platform is that every component will be provided as a Docker image, because this will make it easy to configure, set up the platform in a fast way, remove a component when there is a new version of each of them. And so all the components, starting from the framework, but also the specific components that have been developed for the pilot, will be provided as Docker components. I will show you later how we are working on this. So this is the pipeline for the processing of the floating car data. So as you can see, we have two data sources. Let's say the historic floating car data, then the near real-time data that we get from the web service. The historical data it's a batch file on a file system. The map matching, this component is a Flink job that can be parallelized on different nodes. The result of the processing will be to have the data for a time window that we can choose, can be 5 minutes, 15 minutes, or 30 minutes. Since we have data from the floating car data, we have data every 2 minutes. So we can set windows of from 5 to 30 minutes, and we send this data to Kafka, to the messaging system, and this data then will be consumed by the job that we will start the training of the model, and also by another job that will simply implement the monitoring of the traffic, what is going on now. Then for the first cycle, we have just a simple visualization. Is not, of course, what SET can do with the application, but our aim is to set up the big data framework. So a framework that is based on open source tools. So let's say that we have, for example, we test the pilot on an environment that is composed of 3 nodes. So we have these 3 nodes with 4 CPU core, and we can use we can install one Flink worker on each of this node, and one slot per CPU. That means that we can have a parallelism of 12. That means if we start to work, we start to process an historical file. That means a file that contains a part of the historical floating card data. We can split this job in 12 parallel process. How this process works with this tool, and in our case is Kafka. The model is the MapReduce model, and in Kafka in Flink is divided in the first step. It is the source, that means the ingestion of the data in a parallel way. The map match, that is matching the coordinates to the road segment. Then the key by, that means partitioning the data according to the road segment after the map matching. Then applying a window, that means separating the data in their right time window, and then apply an aggregation, for example, for the number of vehicle and the average speed in that time window. And the last step is the sync. That means the storing the result in a storage system. In our case is Elasticsearch. So very simply, if we can think of separating this process in two parallel with the parallelism that is two. That means, for example, we start to process a file. We can split the ingestion of the data in two processes. That means we can use two machines to do this work, and the same we can do for the map matching. And as you can see, we don't need to repartition the data. That means that it's much easier and it is faster for the platform to process the data till this step. For the next step, as you can imagine, we have to repartition the data, because if we had to separate the data according to the road segment. So the data from one node, at least a part of data from one node can be sent to another node, to the other node. And after this, we can store the data using the sync subtask that can have a parallelism of 1 or 2. But this is just to give a sense of what is going on with this framework when we process the data in parallel. So the input data, as you can see, there is the device D, that is randoms. There is a timestamp, latitude, longitude, the speed, orientation, and transit. The result after the processing is to have the road segment, the start date of the time window, the number of vehicles in that time window, and the average speed in that time window. It's very important to know that the time order is preserved till we do the key by subtask. This is why we can say that in each time window we have the events that have really happened in that time window, not events that happened before and are put in a wrong way in the wrong time window. That is a technical detail, but it's very important. Then for the next cycle, just to talk a little bit about what we are going to do is to extend functionalities, improve what we have now, and lower the boundaries. That means providing better visualization. So as been said before by Jose Maria, we will work on the floating curve data, the historical data, and we will use the historical data after the map matching to train a model, likely a model based on artificial neural network. We are currently testing an algorithm from CERT. And then being able to make prediction from this model. For the improvement of the technology, as has been said before, there will be an improved algorithm for the map matching. And from our side, we will be very. I mean, we will take care of the parallelization of the process, and also of the Dockerization of all the components. What the big data platform has as its contribution is to have a set of components for the frameworks, and a common interface where all the frameworks where the user can have can control what's going on in each of the framework that are used by a pilot, and also a tool to orchestrate all the container. Then we will work also on the improvement on some visualization, also because we need some to visualize, for example, the road segment and the position of the location of the vehicle to see if the map matching is working fine or not. So this is as you can see, is the link to the BigDataEurope website, and the code and the link also to the code repository. And I can show you. I hope that I have still time to show the pilot for the first cycle. As you can see, sorry?
Yes, Luigi, it would be great to see it, just a very short demo, because we're a bit over time.
Yeah, so for the first cycle, we have implemented the Docker components of the framework, and also the specific component for the pilot. Here you can see this component, the one that are used for the first pilot, and we need to start this component in a proper way. So we need to start Zookeeper, we need to start Kafka for the messaging system, the producer that fetch data from the web service, and transform the data and put the data into the message broker in order to be consumed by the map matching algorithm, and then also the storage system for the data, and the application for the visualization. So I will show you what is, for example, now I have started one task on Flink. This is the dashboard of Flink. I have started all the other components. They are already in place. I don't want to go too much into detail into this because it will take too much time. But as you can see, there is a job that is running on Flink and is producing some data and is sending data to Elasticsearch. Is JSON file, and this JSON file can be visualized using Kibana or any other application. We use Kibana because it's much easier to have some visualization without doing any development. So you can see that the data can be visualized on a map, and for example, in order to visualize the number of messages from the road segment, and also have some understanding of the data. For example, we can say the average speed, that 40% of the taxis are not driving, and other have the average speed that is among 29 and 36 and 29 and 51. So yeah, that's all from my side. And in the next, if we will have another webinar, I hope to be able to show more about the parallelization and hopefully the prediction algorithm. That's all from my side. If you have questions.
Thank you, Luigi. That was definitely a good teaser for future webinars and workshops. Unfortunately, we don't have much time left, so I would like to take the opportunity to thank all the speakers for their presentations and also thank our audience for their interest. We will be sharing all the presentations with you online. And thank you and have a nice weekend. Goodbye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye.